Hi, in this lesson we'll be looking at the product rule for differentiation, which follows on from our previous video on the chain rule for differentiation. We'll start off with some basic example on the use of the product rule leading up to exam questions similar to the one I have behind me. So by the end of the lesson, you should be quite skilled in performing the product rule for differentiation. So stay tuned. Before you watch this video, I would suggest that watch the video on the chain rule and then watch this video afterwards. Now, to begin, you need to know when to use the product rule. The word product obviously means multiply. Let's begin by writing down the formula for the product rule for differentiation. So if we differentiate, so d by dx of the function, let's call the two functions u and v. So we have the product of two functions u and v. Both functions here obviously are functions of x. So the derivative of u times v is equal to u dash v plus u v dash. The dash here is symbolizing the derivative of each of those functions. So here you have to differentiate u first, then you times by v, then you plus, you leave the first one by itself and dash the second function, in other words differentiate the second function. Another way of remembering the product rule is you can simply write uv plus uv, dash the first one, and then here dash the second one. And that's a quick way to recall the product rule for differentiation. Now, let's begin with a few examples. I'll start with an easier example. So let's say that y is equal to product of x times e to the power x. Here we have two functions here being multiplied by each other. So that's the first function multiplied by the second function. This is basically the u, and we can call this the v. When you're using the product rule, it doesn't really matter which one you call it, which one you label u and v. In most cases, the one on the left you call u, and the one on the right you can label as v. If we write them out separately, u equals to x, therefore u dash, if we differentiate x, you get 1. V equals to e to the x. V dash equals to e to the x. So the formula dy by dx is equal to u dash v plus u v dash. So we substitute those functions in. So u dash is 1. So 1 times v, which is e to the x, plus u is x, and v dash is e to the x, and that just simplifies to e to the x plus x e to the x. So this was an easier example, straightforward use of the product rule. Let's call this question A. Let's look at a second variation of this type of function. So let's say y equals to x squared e to the x, in which case this is going to be our u. This is our v, so I'll just label them as u and v here. So here, u equals to x squared, u dash equals to 2x, v equals to e to the x, or v dash is e to the x. They've got the formula up there, so dy dx equals to u dash v, so this would be 2x times by e to the x plus u v dash, so that's x squared e to the x, and then obviously I'll leave it like this because that just gives you 2x e to the x. So let's look at a third variation of this question. Y equals to x squared e to the x to the power 3 this time. So we have this as the first function, which is our u, this as the second function, which is our v. So here we have u equals to x squared, u dash equals to 2x. We have v as e to the x cube, v dash. Now, to differentiate this, we're going to now use the chain rule for differentiation. So here there's two layers to this function. The outer layer is the exponential. So if you differentiate the e, you get the same e back with everything inside that exponential. Then you times by the derivative of the second layer, which is your x to the power 3, and that gives you 3x squared. So you get 3x squared e to the x cubed. So Therefore, dy dx is equal to, so u dash v, so u dash v, so that's 2x e to the x cube, plus uv dash, so uv dash, so that gives you 3 times x to the power 4 times e to the power of x cube. And that's the differentiation done. What you can do here, which may be relevant if there's more parts to this question. Sometimes when you have a differentiation question, part A might be to differentiate, part B may be to solve, to form some sort of equation to solve, or it might be that find the coordinates where the gradient is 0. So it may be useful to factorize any common factors here. So we can see that we can pull out the x, and we can pull out the exponential x to the power 3, and we will be left with 2 here. Plus 3x cubed will be remaining inside the bracket. Okay, let's look at a slightly different question now. So y is now the product of x and sine x. Before we had x and e to the x, and now we have x multiplied by sine x. So that's u, and this is our v. So we want to perform dy by dx. dy dx is u dash v plus u v dash. So we have u as x, therefore u dash is 1, v equals sine x, v dash equals to cos x, because sine differentiates into a cos. So if you put that into a formula, so u dash v, so 1 times sine x is sine x, plus u v dash, that gives you x cos x. And this is our answer. So let's call this part A. Let's now look at a different variation of the same question. Y equals to, let's say that's 4x to the power 3 times by sine of x. So that's our u. This is our v. So we have u equals to 4x to the power 3. U dash is therefore 12x to the power 2. V equals to sine x, v dash equals to cos x. So therefore dy dx would be u dash v, so that gives you 12x squared sine x plus u v dash, so that's 4x cubed times cos x. And one more variation, if y equals to 3x to the power 5, let's say, times by cos of 6x. Okay, so we have u times v here. So u equals to 3x to the power 5. U dash equals to 15x to the power 4. V equals to cos of 6x. V dash, again, chain rule here, differentiate the cos, that gives you a minus sine 6x, and then differentiate the 6x, that gives you a 6. And then use the formula dy dx equals to u dash v, so u dash times v, we have 15x to the power 4 cos 6x, and then plus uv dash, so u times v dash, and obviously you've got a negative number here, so 3 times minus 6 is minus 18, and you got x to the power of 5 sine 6x. Okay, so the third type of question is the product of x and ln x. Again, I'm going to look at different variation of that same question. So this is our u, this is our v. So u equals to x, so u dash equals to 1, v equals to ln x, v dash equals to 1 over x. So ln x differentiates into 1 over x. So the formula for dy dx using the product rule is u dash v plus u v dash. So u dash times v, so that gives you ln x plus u times v dash, so x times 1 over x. So if you do x multiplied by 1 over x, that's x over x, which is simply 1. So when you multiply x with 1 over x, always remember to simplify your answer. No matter how many times I tell my students, someone always forgets to simplify a simple expression like this. So look at the powers of your x's and obviously give the final answer simplified. So here we have u and v dash. So u is x and v dash is 1 over x, which gives you 1. Right, let's call this question A. Let's look at a different variation of the same type of question. So y equals to, let's say, x to the power of 3, and we have ln of 5x. So this is our u, and this is our v. So we have u equals to x cubed, or u dash equals to 3x squared. V equals to ln of 5x. V dash equals to, now here we're going to apply the chain rule. So differentiate the ln will give you 1 over 5x times by differentiation of 5x is simply 5, and then if you simplify this, it gives you 1 over x. In other words, whenever you have ln of a multiple of x, the answer will always be 1 over x, because you got the 5 that's in the denominator and the 5 that you multiply by, you will always cancel out. Whatever coefficient you have, it will cancel out when you differentiate. So dy by dx is equal to u dash v, so u dash v, so that's 3x squared times ln 5x plus u v dash, so u times v dash. So here again, simplify, u times v dash, x to the power 3 times by 1 over x simplifies to x to the power of 2. So that just gives me x squared when I perform u times v dash, and that's the derivative done. Right, so let's have a look at this function here. Here we have y equals to 2 to the power of x, which is going to be which will be our u, and we have sine of x squared plus 1 inside the bracket. This is our v. So we can begin by labeling the u as 2 to the power x. U dash, whenever we differentiate an exponential function, it will give you the same exponential function back, but then we have to multiply by the ln of the base number, which is 2. Obviously, this is going to be the constant that comes out and multiplies our exponential. So v equals to the sine of x squared plus 1. Therefore, v dash would be equal, sine differentiates into a cos, so it gives you cos of x squared plus 1. And then you times by the differentiation of what's inside the bracket, and if you differentiate that, that gives you 2x. So dy by dx is equal to u dash v plus u v dash. So u dash times v. So here we have 2 to the x ln 2 is that constant, times by v, that's the sine of x squared plus 1, plus u v dash, so u v dash. And here we have 2x times all of that, so we have 2x, we have 2 to the power x, and we have our cos of x squared plus 1. Here you have to be careful because of the exponential, the base number 2. It may get confusing with the other 2 there. These are 2 different base numbers here, because this has a power of 1 and this has a power of x. So they have 2 different powers, so you have to keep them separate. So just put brackets around them, and it will, then you won't forget that these are, you can't multiply the 2 and the 2 here because they are different base numbers. So that's the answer to this derivative.